Welcome to our review session for the fourth exam, the last exam for managerial accounting for the fall 2022 semester. We're looking at the practice set. I also want to mention that I did a very brief, about 8-minute tutorial on the Chapter 28 problem. So if you are stuck on that, if you have any questions, you don't even know how to start, I would suggest that you go to the Chapter 28 reference materials folder in Brightspace, and you'll find a new link from today, from earlier today, related to that Chapter 28 problem. And what we're going to do during this time then is go through the practice set for the exam. So remember, to get to the practice set, you need to, in See Now, click on the link that says assignments I can practice now, or the link that says all assignments. It doesn't show up in the assignments you can take now, which is the default, because it's not graded. You can see that there are, compared to other exams, very few exercises here. So we're not going to, it's not going to take us a long time to go through each one of these. In fact, all of these exercises are from chapters 26 and 27. So chapter 28, there wasn't any of what I consider the doing of accounting, where we're doing calculations and using formulas and things like that. For some reason, these exercises are in a bizarre order. So I apologize for that. And I will go through them in the order that they present to me here, but it's possible that they appear to you in a different order. And so just go by, you may have to jump around a little bit. So I'll leave my navigation open over here on the side so that you can see the exercise numbers as we go through them. As you can see, these are all brief exercises, which means that they are a little bit shorter, faster, a little bit less comprehensive than what we have done in class, which are just the regular exercises. But mostly the brief exercises are probably more similar to some of what we do on the exam. So definitely all of the concepts that we're going to be covering in these 7 exercises, you can expect to see on the exam in one form or another. So the first exercise that's appearing in my set is 26, chapter 26, exercise, brief exercise number 2. You'll also notice that these are algorithmically generated, at least most 5 of the 7 are. So all the ones that have the ALGO, it's possible that the numbers that you're seeing in your problem, some or all of them may be different. So the procedures, the calculations that we do, the approach will be exactly the same, but if you want to complete your set, make sure that the numbers that you're using in your calculations are from your problem, not from the ones that I have, because again, they may be different. So this is, again, brief exercise 2 from chapter 26. It is on the cash payback period. So remember, when we're doing capital investment analysis, we talked about 4 different approaches that we might use. The first 2, cash payback period and accounting rate of return or average rate of return, do not take into account the time value of money. So one of the advantages of those 2 methods is that they're quick and simple, but the disadvantage is they don't take into account the time value of money, and they may not even take into account, as the cash payback period does not, they may not take into account all of the cash flows associated with the project. They may only be looking at the first few years of that project. Also, for any one of these 4 approaches, the company needs to decide what is acceptable for them. So for the cash payback period approach, they need to decide in advance what's an acceptable time for us to wait to get our money back from this project. And that might be 3 years, 4 years, whatever, but they need to decide in advance how long is too long, what's the outside that we're willing to wait, and then do this calculation and compare the answer to the standard that they had set up front. So for this So for this exercise, I'm just gonna get my annotate up here. A project has estimated annual net cash flows of $54,500. It is estimated to cost $267,050 for the project. And then it's going to bring in $54,500. As long as the project has equal annual cash flows as this one does, we can simply take that upfront cost and divide by the annual expected net cash flow. And we see that it would take 4.9 years to get our money back. And then, as I said, the company would have to decide, is 4.9 years too long? And I can tell you, under most circumstances, the answer to that would be yes, that's too long. Typically, with the cash payback period approach, especially because it doesn't take into account the time value of money, we're looking for a shorter time frame when the time value of money has less impact on it. So again, make sure you're using the numbers that you have in your exercise. And let's move on then. The next one I have in my set is brief exercise 1 from chapter 26. And this is the average rate of return, or what is sometimes referred to as the accounting rate of return. So the advantage of this approach is, again, it's simple. It's numbers that we're used to looking at because it is based on accounting income. And so that makes it a little bit maybe more comfortable for some people than another approach might be. It does take into account accounting income, which means it's including things like depreciation, non-cash expenses. It doesn't take only cash flows into account, does not take into account the time value of money. Determine the average rate of return for a project that is estimated to yield total income of $405,000 over 6 years, has a cost of $690,000, and has a $60,000 residual value. So the first thing we want to do is calculate the average value of the project, or the average investment. Oops. And the way we do that is we take the original cost of the investment, which is $690,000, and we take the cost or the value at the end of the project, which is that residual value. And if we're using straight line depreciation, that the value of this investment is going to go from 690 down to 60,000 in a straight line fashion. And so we can just average that beginning and ending value together to find the average value each year of the investment. We don't even need to know how many years. Excuse me. And so we add those two together and divide by 2. And we find that the average value of the investment is $375,000. We also need to know the average annual income of the project, and it did not give us that. It gave us the total income expected from the project over its useful life. And so for this one, we do need to know that useful life, that $405,000 is expected to come in over 6 years. And so that would be an average income of $67,500. Now we can calculate our accounting or average rate of return by taking the average income and dividing by the average cost of the investment. And I got 0.18 or 18%. Again, this is another one that is generated algorithmically, so your answers may differ from mine, but the approach you take, finding the average investment, finding the average income, and then calculating the average rate of return. The formulas that you use are the same. Yours may just have different numbers. I think let's finish up the chapter 26 one. So I said I was going to go in order, but that probably doesn't make sense. Let's do the chapter 26 ones, and then we'll do the chapter 27 ones. So I'm jumping ahead to the chapter 26 brief exercise number 3, which is the net present value, or NPV approach. This is, I think, the gold standard for analyzing capital investments, because it does take into account every single cash flow throughout the life of the project, and it does take into account the it does take into account the time value of money. Excuse me. So this exercise tells us we're looking at a project with estimated annual net cash flows of $7,500 for 5 years, and the upfront cost is $42,500. So the fact that it's an annual cash flow of the same amount each year means that we're going to use the annuity concept. We have 2 different tables, as you know. We have a table for a single cash flow at the end of some number of periods, and then we have a table for a regular cash flow that happens each year or each period at the end of the period. And that's what we're going to be using here. The company must set an acceptable rate of return. And as we discussed in class, that's usually based on some version of the weighted average cost of capital. And this company has set that minimum at 6%, which is pretty low. That's probably not very realistic. But so in the table, we go to the column with the 6% at the top, and we go down the column until we get to the number of years, number of periods that corresponds with our project. So the factor from the table you can see is 4.212. So the first thing we're asked to calculate is the net present value of the project. So we take the annual cash flow and we multiply by the factor from the table. So if we bring in $7,500 a year for 5 years, that's bringing in a total of $37,500. And this is kind of funny. So even without taking into account the time value of money, the project would only be bringing in $37,500. Didn't it say the upfront cost was $42,000? I need to scroll up to be able to see that. Yeah, $42,500. So $7,500 a year for 5 years only brings in, excuse me, $37,500. Even without doing any more calculations, we know we're going to say this project is not worth it. It has a negative NPV. But let's finish the calculation anyway. 7,500 multiplied by that factor, 4.212, and then so that's $31,590. We then subtract from that the $42,500 that it's going to cost us up front, and we get a very big negative NPV. It's okay. We can still talk about the principles involved. I'm going to write this off to it was generated algorithmically. No individual sat down and said, gee, we've got to make sure that this makes sense. Nobody would ever think that a project that costs $42,000 up front and only brings in 37.5 over 5 years is going to be worth it. But the rule is for our NPV calculation, for our NPV decision making, anytime that the NPV is at least 0. So 0 is kind of the break-even point. That would mean that the project returns exactly 6%, which is the minimum the company requires. Any amount over that, even $1 positive, means it brings in more than the 6% that's expected. But the second thing we're asked to calculate then is the present value index, which is the relationship of the present value to the upfront cost. Now, this is not a terribly meaningful number when we're starting with a negative NPV to anyway, but again, we can still do the calculation so you can practice with it and see what this would look like. So the present value index is calculated by taking the present value in dollars and dividing by the upfront cost, again, in dollars. And I got negative, what does it say, rounded 2 decimal places. I got negative 0.24. Oh, whoops. Yeah, I apologize. I need to make it into an index. So rounded to 2 decimal places, 24.24. I don't know why it's not liking that. I don't know if it's because of the negative. It's definitely how we do the calculation. Not sure why it's not. Oh, no, I know what I'm doing. Sorry. Let me redo the calculation. Probably my mistake here. Let me redo that calculation. So here, I still have that number on my calculator. So the total returns of the project. I was not thinking about that correctly. Total returns of the project divided by the cost of the project. Oops, what was it? 42,500. My mistake. 42,500. So there we go. Make it an index. Oops, wrong square. That's what I get for sometimes. And it's not actually making it an index now. Okay. Yeah, so that was a difficult one because I'm trying to talk and write on the screen and punch my calculator. But let me backtrack on this and explain. So the present value index is calculated as I have it on the screen now as the total cash inflows discounted back to present value divided by the upfront cash outflow. So we're looking for something that's greater than 1. One of the advantages of using the present value index is it allows us to compare the relative profitability, if you will, of projects that maybe don't have the same upfront cost, where it doesn't make sense to look at the dollar amount because, you know, a return of an NPV of $1,000 on a project that cost $1,000 is huge. The NPV of $1,000 on a project that cost $1 million, not so much. So the index allows us to compare two projects of different sizes. The other issue that I have is that this is an index, and normally an index means that you're expressing it as a percent, but without the percent sign, and that's why I wasn't sure what they were looking for here. So the present value index can reasonably be expressed as 74%. So your return is 74% of the upfront cost. You're definitely looking for something greater than 1, where the return is more than the upfront investment. And that would always give you a return that's greater than, or an index, excuse me, that's greater than 1 or 100%. So I'm not sure why in this example they did not use an actual index, but they used instead just the decimal equivalent of that index. And we have one more question from chapter 26, and that is the internal rate of return. And so this is the one where we're kind of doing guess and check. So we have to use the table to interpolate to find, we calculate the, to put this in the terms that I've been using, we calculate the factor up front, and then we find where would that factor fall on the table. And then we decide, is that good enough? As I suggested at the very beginning, it's really more appropriate for a company to decide up front, here's an acceptable rate of return, here's an acceptable payback period, here's an acceptable NPV, and then do the calculations and decide, does that meet our pre-established criteria? The reason for that is because it becomes too easy. If you don't decide up front what's acceptable, it becomes too easy to look at a number and say, okay, yeah, that's close enough, without actually establishing a standard up front. So, internal rate of return. A project is estimated to cost $82,848 and provide annual net cash flows of $32,000 for 4 years. We're asked to determine the internal rate of return for this project using the present value of the annuity of $1 at compound interest table shown here. So to do the calculation, we take the upfront cost, and we divide by the annual cash flow. Oops. And that gives us a factor of 2.589. Excuse me. And then we go to the table and say, if this is a 4-year project, so we're in the year 4 row, if this was a 4-year project, what percentage return does this factor 2.589 correspond with? And so I can see right here at the very end of the row, 2.589, if we then go up that column, corresponds with a return of 20%. And so with that 20% return, the company decides, is that good enough? 20% sounds really good, but it may not cover their cost of capital and then the expected return, over and above that. And so it's kind of going at it backward from the net present value, where we find the factor and then we discount the future cash flows back to present value and say, how does that compare to the upfront cost? But it's really the same approach, only it's reversed. And so that's chapter 26 on evaluating capital investment opportunities. Any questions about anything from that? We just have a couple exercises related to chapter 27 on lean manufacturing. So let's do these in order, as long as we're jumping around anyway. We'll go to, from chapter 27, brief exercise number 1. This one is not algorithmically generated, so anyone watching this video should have the same numbers in your problem that we have, or that I have in mind. Blues Incorporated manufactures jeans in the cutting and sewing process. Jeans are manufactured in 40 jean batch sizes. The cutting time is 5 minutes per jean. The sewing time is 20 minutes per jean. It takes 2 minutes to move a batch of jeans from cutting to sewing. Compute the value added, non-value added, and total lead time of this process, and then compute the value added ratio. So the cutting time is 5 minutes per jean and sewing time is 25 minutes. Those are the 2 steps in the process that are adding value to the process. We do this in batches of 40. My annotation tool back up here. And so let's think about how much time it takes for cutting. It's 40 pairs of jeans, each of which take 5 minutes. So that's a total of 200 minutes that the batch sits at the cutting process. And then the sewing process is even worse. 40 pairs of jeans, each of which takes 20 minutes to sew. And that's 800 minutes of time sitting at the sewing process. And it takes 2 minutes to transfer the batch from cutting to sewing. Excuse me. Doesn't tell us anything like the exercise we did in class about transport from, from the material storeroom or from sewing to whatever comes next. So these are the only pieces that we have available to us. So we take that, the total time then is 200 plus 800, 1000 plus 2 for transfer. That's 1002 minutes of total time for the batch. And of that, 25 minutes is value added, which means that the other 977 minutes are non-value added time. So the value added ratio then is the value added time of 25 minutes divided by the total time of 1002 minutes, and rounding that to one decimal place on the percent would be 2.5%. I got 2.495, which rounds to 2.5%. In other words, 97.5% of the time, the jeans are just, each pair of jeans is just sitting there waiting its turn. So not ideal. Definitely a much lower value added ratio than what we would hope or expect to see. Lots of room for improvement, which is helpful. And for our example in class, we redid this calculation and said, what if we reduce the batch size? So under lean manufacturing, again, as we said in class, the ideal batch size is a batch of 1. That may not be practical in reality, but definitely larger batch sizes are going to be much less efficient, as we can see here with this 2.5% value added ratio. Let's go on then to, let's see, brief exercise 3 from chapter 27 is related to lean accounting. This is another algorithmically generated exercise, so it's possible yours has different numbers, or some of the numbers may be different than what you see on my screen. The annual budgeted conversion cost for a lean seller, $474,000 for 2,000 production hours. So I just want to calculate while we're talking through this. Let me put it over here in the blank white space. So $474,000 for 2,000 hours is a cost of $237 per hour for the conversion costs. Each unit produced by the cell requires 6 minutes of cell process time. So $237 per hour is $3.95 per minute. And if it's 6 minutes per unit, that would be $23.70 per unit. Yeah, it doesn't give us anything more than that. So again, the way I determined that, I took the hourly rate divided by 60 to find the rate per minute of $3.95, and then multiplied by 6 minutes. Would have been faster because 6 minutes is 1/10 of an hour, 6 out of 60. I could have just taken that 237 and divided by 10 if you were trying to be more efficient or lean in your processes. During the month, 1,170 units are manufactured. So, and the estimated materials cost are $37 per unit. We are asked then to journalize 3 entries. First, the materials are purchased to produce 1,230 units. So remember, one of the advantages of lean accounting, and I talked about in class, backflush accounting. This is not backflush accounting. We are not asked to put everything into cost of goods sold and then back it out at the end if it's not actually sold. We are doing the standard lean accounting, which again, as we did in class, means that we are combining transactions whenever possible. And so one item that is combined is our raw and in-process inventory, because the concept of just-in-time means that we are aiming for these to be near zero at the end of the month. So rather than keeping those separate, we combine them into just one entry. And in this one, we are reporting using standard cost, this $37 per unit that we estimate our materials cost. Letter A says we purchase materials to produce 1,230 units at $37 each. Yeah, so that would be $45,510 worth of materials are added to that combined raw and in-process inventory. Doesn't say how we paid for them, so I'm going to say accounts payable, could be cash, but I'm surprised that it would have both of those as options because it doesn't tell us how we paid for them. We'll go with accounts payable. That's probably more likely for a manufacturing company. They're probably not paying cash for their raw materials. Conversion costs are applied to 1,170 units of production. And so those conversion costs are applied based on our expected cost of, we already calculated here on the screen, $23.70 per unit for each of the 1,170 units. Again, these are standard costs. These are based on the budget or the standards that we had established before we began production. And then the cell completes 1,110 units, which are placed into finished goods. So we're going to move those units out of raw and in process and into finished goods. And let's see, the total cost per unit would be the $23.70 that we calculated for conversion costs. Remember, that's the combination of the direct labor and the manufacturing overhead. So we lump those together to save time. We just call them conversion costs. $23.70 per unit plus the $37 for raw materials. The standard per unit cost is $60.70. And if we completed 1,110 units, oops. Don't know why my screen, I don't know what that line is doing on there. I don't know why my keyboard did not want me to write, but again, I calculated the cost, the standard cost per unit, $23.70 for conversion cost plus $37 for materials, total of $60.70 multiplied by the 1,110 units we finished. And we move those costs at standard. We move those costs out of raw and in process into finished goods. Now, at the end of the period, we would need to, of course, reconcile these standard costs with our actual costs and identify any variances and account for those. Okay, one more exercise. One more exercise that is oops, let me get that writing off the screen. That is exercise 2705. And this is not an algorithmically generated exercise, so everyone should have the same everyone should have the same here. Rowan Company incurred an activity cost of $105,600 for inspecting 40,000 units of production. Management determined that the inspecting objectives could be met without inspecting every unit. Therefore, rather than inspecting 40,000 units of production, the inspection activity was limited to a random selection of 5,000 units of those 40,000 units of production. Determine the inspection activity cost per unit on 40,000 units of total production both before and after the improvement. If required, round per unit amounts to the nearest cent. And so we have to make an assumption here that that these costs are all variable costs. So if we cut down the number that we are inspecting, we will see a corresponding reduction in those total costs. It does not say that, but we have to assume that. And so let me show you some, show you the calculations on the screen here. Again, assuming that these costs are all variable. Now, I'm sure that some of those costs are variable, but I would also expect that maybe some of those costs are fixed. And if they are truly fixed, we're taking the same costs and dividing them over a smaller number of units. But for the sake of this exercise, we will assume, even though it does not say, we will assume that these are completely variable costs. And so based on the data that are provided, $105,600 spread over 40,000 units is an average cost of $2.64 per unit. So if these truly are strictly variable costs and we inspect only 5,000 units, our total cost then would be $13,200 for inspection. And even though we're not inspecting all units, we're going to spread those costs over all of the units as the total activity cost for inspection. And that brings our cost for inspection, the inspection activity, down from $2.64 per unit that we produce to only 33 cents per unit that we produce. It's still $2.64 for each unit we inspect, but we're going to spread that cost of the inspecting activity over all of the units. If it turns out that some of these costs, some of the $105,600 was actually a fixed cost, we would have to take that into account in determining our total cost of inspecting that smaller number of units. So we can't do that with this exercise because it doesn't tell us what percentage is fixed. In fact, we're assuming that it's all variable. And if we go from inspecting 40,000 to only 5,000, which is 1/8 of the total, that our costs will be cut down to 1/8 of the total. Okay, so that's our entire practice set for this exam. As you know, because we saw it in class, the exam only covers 3 chapters, and chapter 28 was a very short chapter for us and more of a theoretical or principles based about the balanced scorecard and corporate social responsibility. Not really doing calculations, doing accounting like this. So, any questions? I'm going to pause the recording.